Hello everyone. Today we are gonna be simulating natural selection. So what is natural selection? It's like where you have a look, I'm just gonna show you. So we start off with some cubes and they're gonna eat the food. And I can change the food scarcity to 3, which is very scarce, and 7, which is lush. Okay, the equilibrium zone is the limit of how many little dudes there can be, and the pop just the population. So now if we speed this up, as you can see, they change color to blue. This means that they're becoming more speedy, and if they aren't speedy, then okay, if they aren't speedy, they won't catch up to the food. But now there's a predator. This red cube, this red large cube is a predator. And each of these little cubes are running away. But the problem is that it costs energy to run away from them because they're increasing their speed. And increasing their speed costs a lot of energy. And if I click space, as you can see, we can see that they show us their energy and their speed. As you can see, the one that the number that they say on the left is their energy, and the number that they say on the right is their speed. And they also need speed. I mean, they also need energy, so they reproduce. So now, if I just speed it up, you'll see that increasingly over time, blue and green cubes are more abundant because they are running away. Now, if I increase the food scarcity to 7, which means it's very lush, as you can see, there's even more blues and greens because there is more food for everyone, so they can survive longer while running away from the predator. Now, if I slow it down, if I do 5, as you can see, there's less blues. And now, if I set it to 3, if we just speed it for a longer time, and we're almost there, you can see that there's barely any more light blues. There are only purples, magentas, or just dark blues. Very rarely can you find light blues. That's because there's less food for everyone, so they have to spend less energy to survive. As you can see, the predator is eating more of them because there is less food and they're slower because they're trying to uh, save energy so they don't die and reproduce. Okay, and we can also increase the equilibrium zone to 200, and as you can see, there is more speedy ones. That's because it's more now, it's a more bigger challenge to find food, so they waste efficiency over speed, so they can find more food faster, so they can survive and dodge the predator. As you can see, that doesn't always work, and turns out that it's a very bad strategy. As you can see, a lot of cubes are running away from a certain radius away from the predator. The ones, if you find any cubes that are frozen, that's because they have no more energy and they cannot spend any more energy to run. They either have to be lucky enough to eat a pellet before they run out of energy and get killed. And now if I just slowly decrease the equilibrium zone, which is risky because it can lead to death. Note, I'll increase it up to 125. We can just turn the scarcity up to 7, so now they all survive and they're all happy now because they have more food and they can speed up faster. As you can see, we put on turbo mode, and you're gonna start to see that a lot of the purples are starting to fade away. There is still more. That's because they were adapted to low scarcity. I mean, it was very scarce, but they were very adapted to being very scarce. So it takes a little bit more time for them to adapt to the less scarce region because there's literally no difference. But a lot of competitors can eat the food that they target, and so they waste some energy so they can get food and survive, causing them to speed up. As you can see, there's more greens and light blues than there are purples. Here you can see that the only ones that die are the ones that have no energy left, and so they just get blocked. So, further ado, here's what the code looks like. We have 3 sprites instead of 1 because we need them for the pellets, for the cubes, and for the cube predator. Here is the cube organism, which is the little cube you see. And here the code. As you can see, they have speed and energy, and the energy is very important for them because they need to spend energy so they can move, reproduce, and live. If they don't have any energy, they will die. And there's a simple food particle that just waits until they touch a cube organism and then waits a second so the cube organism gains energy and then deletes. I mean, it's very, really simple. So, yeah. And there's the cube predator. This is the most simple one. All it does is it hides, it sets the rotation style to left, right, so we don't have diamonds instead of squares. And it waits until the population is greater than the equilibrium zone minus 7. So there is a little less cubes than the maximum amount. And then it shows and then it starts just moving, and as you can see that's what's happening. And in the cube organism, here it checks if the distance to the cube predator is less than 50, then they point towards the cube predator, but you don't see it because the direction is left right. They turn 180 degrees to face away from it and then move speed divided by 2 times 1 plus turbo mode enabled. It's actually an extension from turbo warp, so you're not gonna find this block in Scratch or any Scratch extensions unless you switch from turbo warp to Scratch. Be warned that if you have extensions that are not in Scratch and you import them, they'll get deleted and nothing works, so be careful. And so this is the natural selection in Scratch, as you can see. This is the simplest as it gets. Usually most of them have more different parameters as sight and other stuff. And there also has to be more cube predators, but I decided for simplicity I only make one so we don't have to use lists to track their X position and Y position. So I hope you enjoyed this video. Don't forget to subscribe and like to my other videos. Thanks if you did. Bye bye. But what do you mean?